Hey guys, welcome back to Sleepy Science, the only channel where we take cosmic nightmares and turn them into bedtime stories. Tonight, we're diving into one of the universe's most dramatic overachievers, black holes. It's the universe, 13.8 billion years old, and you're floating peacefully when suddenly space decides to get weird. Somewhere out there, a star collapses under its own ego, folds into itself, and becomes a black hole. Congratulations! You've just stumbled upon the universe's most terrifying do not enter sign, except the sign is invisible, the door is everywhere, and if you step through it, you're gone forever. Cozy stuff. A black hole is basically gravity hitting the gym too hard. The pull becomes so strong that not even light, the entire universe's speed champion, can escape. That's why they look pitch black. The edge around them is called the event horizon, also known as the point of no return. Good luck, buddy, or welp, that's it for you. Anything crossing that line ships, stars, hopes, dreams gets dragged inside and never comes back out. So before you get comfortable, go ahead and like the video and subscribe, but only if you genuinely enjoy wandering into existential darkness with me. And let me know in the comments where you're tuning in from and what time it is. It's always fun seeing who's falling asleep under which patch of sky. Now, dim the lights, maybe turn on a fan for that soft cosmic hum, and let's drift into tonight's gravitational disaster together. Inside a black hole, physics stops pretending to make sense. Space and time twist around each other like they're auditioning for a cosmic dance competition. Matter shrinks. Dimensions warp. The universe basically shrugs and says, yeah, you're on your own now. But despite how dramatic they are, black holes aren't cosmic mistakes. They're predicted by Einstein's equations, like the universe's way of saying, yes, I meant to do that. Einstein's theory of general relativity, published in 1915, described gravity not as a force but as a bend in space-time itself. Heavy things sink into this space-time fabric, and lighter things roll toward them. Simple, right? Well, not simple enough. Because physicist Karl Schwarzschild looked at Einstein's math and said, cool, but what if all the mass collapses into one infinitely tiny point? And suddenly boom, black holes popped out of the equations like unwanted bonus content. Even Einstein was like, no way those really exist. Spoiler, they do. For decades, scientists weren't sure what to call these cosmic monsters. Collapsed stars, dark stars, and my personal favorite, frozen stars, because from far away, it looks like time stops at the edge of a black hole. Imagine falling toward one and watching the universe wave goodbye in slow motion as you freeze in place. Charming. Absolutely charming. It wasn't until 1967 that physicist John Wheeler said, let's just call them black holes, and everyone else went, yeah, that's it. The name stuck because it sounded mysterious, ominous, and slightly rude. Perfect for something that swallows entire stars for breakfast. Black holes became iconic overnight, invisible, unstoppable, and endlessly hungry. Stellar mass black holes are the grand finale of a star's life, emerging from supernova explosions in a cosmic fireworks show. Picture a massive star, juggling two forces, gravity pulling inward, desperately trying to collapse the star, and the outgoing push from nuclear fusion, giving it the strength to hold on. Eventually, for those hefty stars larger than our sun, this balancing act comes to a spectacular end when they run out of fuel. When the core collapses, it's less than a second before we witness a catastrophic outburst that sends outer layers flying away like confetti at a wild party. As the core crumbles under gravity's relentless grip, there comes a moment when even neutron pressure can't save the day. If the core is massive enough, nothing can stop its downward plunge into oblivion. It's cosmic chicken, and gravity wins. Past the point of no return, this collapsing core morphs into a black hole, leaving behind a region where space-time is warped like a pretzel. You won't see this mischievous entity, but you'll certainly feel its gravitational pull sneaking around, quietly influencing its surroundings. These stellar black holes, often weighing between 3 and a few dozen solar masses, are like the universe's well-kept secrets. Astronomers believe there might be millions of them scattered across the Milky Way. They lie quietly, each one holding the remnants of a once mighty star behind an event horizon, the ultimate point of no return. And if you think about it, they've become silent witnesses to the cosmic drama that unfolds, shimmering just out of sight while feasting on nearby material, practically hiding in plain sight. Now, if you thought those stellar black holes were the heavy hitters, wait until you hear about their bigger cousins, supermassive black holes. These cosmic leviathans occupy the hearts of large galaxies and carry a gravitational punch that could weigh in at millions or even billions of solar masses. Their exact origin is shrouded in mystery and could be the result of tiny black holes merging or enormous gas clouds collapsing over eons. Regardless, these colossal beasts have been busy gobbling up gas, stars, and whatever else comes within their reach, shaping not just their home galaxies but the contours of the universe itself. At the center of our very own Milky Way lies Sagittarius A, a gargantuan black hole, approximately 4 million times more massive than the Sun, wedged into a space smaller than Mercury's orbit. Imagine all that mass concentrated in such a small area. It's like trying to fit a sumo wrestler into a Volkswagen. Though it's hidden behind clouds of gas and dust, astronomers provide us sneak peeks as they track stars zipping around this celestial beast, their wild orbits revealing the invisible force that keeps them in check. In 2019, the Event Horizon Telescope team achieved something spectacular by snapping a picture of a black hole's shadow, and then in 2022, they set their sights on Sagittarius A itself. The resulting image showcased a fiery ring of hot gas wrapping around a gaping void, a heart-stopping moment in astronomy. That ominous shadow represents an event horizon, where all light and matter meet oblivion. It's both terrifying and fascinating. Black holes, despite being the ultimate monsters of darkness, showcase themselves through the brightness of surrounding gases. The irony of black holes is astounding. They are the sneaky devils of the universe, consuming anything that dares venture near without emitting a single ray of light. It's as if they're the ultimate cosmic black holes, absurdly enticing yet profoundly dangerous. They remind us that the universe is full of surprises, with luminous mysteries lurking behind light and cosmic curvature, proving that even the darkest places can shine through with brilliance. Surrounded by the most dazzling phenomena in the universe, black holes might seem innocuous, but they're anything but. As matter spirals inward, it forms an accretion disk, a spectacular disco of gas swirling so rapidly that friction and compression heat it up to millions of degrees. Bright as a supernova, this disk glows in everything from visible light to X-rays, a cosmic light show that tantalizes space enthusiasts across the galaxy. Now, let's talk about those dramatic jets. Picture this: particles zipping away from near the black hole at jaw-dropping speeds, almost the speed of light. These jets, launched by twisting magnetic fields, can stretch out for thousands or even millions of light years. They're like cosmic fire hoses blasting energy outward. When we catch a glimpse of these radiating displays from afar, it becomes clear that black holes aren't just lurking in the shadows. They're the life of the party, throwing light and energy everywhere. While all black holes have their secrets, the stealthy ones chasing down matter create a visual feast. Instead of plunging straight into the black hole, the gas and dust spiral around it, forming a halo that dances through space. As different parts of the disk spin at varying speeds, the friction cranks up the heat, creating a colorful glow across the electromagnetic spectrum from cozy radio waves to fiery gamma rays. And guess what? The innermost regions shine the brightest, giving astronomers vital clues about the black hole's mass, spin, and how ravenously it feeds. Still, there's something uniquely poetic about the boundary known as the event horizon. This magical invisible line is not made of matter but represents a point in space-time where escape becomes a cosmic impossibility. For a black hole with a mass similar to our Sun, this boundary extends about 3 kilometers outward, while gargantuan supermassive black holes may boast event horizons covering millions of kilometers. It's like the universe's ultimate no-return policy. As matter approaches the event horizon, time itself begins to warp, courtesy of gravity's tight embrace. To an outside observer, it's like watching a slow-motion movie with an endlessly stretching image, but for anything daring enough to cross over, time stands still, and they plunge headlong into oblivion at finite speed. Ain't physics fun? Yet, The black hole's wild antics don't stop there. Occasionally, they unleash astonishing jets that turn dormant galaxies into sparkling beacons. When these jets align just right, aimed straight at Earth, black holes morph into dazzling beacons called blazers. It's like having a front row seat to the most intense light shows in the universe, reminding us that these cosmic entities are not just destructive, but also incredible architects of energy and matter throughout space. Once you cross the threshold of a black hole, all roads magically lead towards the center with no detours, no escape routes. It's like being on a roller coaster that only drops downwards. You're in for the ride of your cosmic life. The event horizon stands as the ultimate bouncer, letting you in with a sly grin but never letting you out. Time behaves like a rowdy party guest under the heavy influence of gravity, stretched, twisted, and completely out of sync with the outside world. Imagine this: an astronaut bravely hovering near the event horizon experienced time like everyone else, while people watching from afar would think they were in a slow-motion spectacle. Their voice would slur like a karaoke singer after one too many drinks, while their clock ticks at a glacial pace. To the poor distant observer, it's as if time forgot about the astronaut and decided to hang out elsewhere for a while. That's a cosmic case of you snooze, you lose, if you ask me. Now, diving into a black hole might sound like a thrilling adventure, but it's not all smooth sailing. For those daring enough to approach a stellar mass black hole, crossing the event horizon can feel more like a roller coaster drop, with tidal forces throwing you around like confetti at a party. But fear not. If you're entering a supermassive black hole, it's more of a gentle breeze than a violent shake. You might cruise through its event horizon seamlessly, which sounds pretty chill until you realize what that really means. Once you've sailed past that point of no return, the universe might still seem visible from your view. It's like looking through a one-way window you can see out, but the universe can't see you anymore. What fun, huh? The light from distant stars will smudge and stretch, but your attempts to send out a signal will be met with the heart-wrenching silence of the void. You find yourself trapped in a cosmic limbo where every mental compass direction leads deeper into the singularity. Talk about a party that just won't let you leave. Inside the event horizon, the laws of space and time are doing an oddly choreographed dance. While we typically see time as a one-way street, inside a black hole, it flips the script. Moving toward the singularity isn't optional. It's as unavoidable as the coffee craving that hits every morning. Accelerate as much as you want, but the singularity, your inevitable future, will keep beckoning like a well-meaning, albeit pushy, friend insisting you join them for a late-night snack. At the heart of the black hole lies the singularity, a funky little mystery where regular physics takes a vacation. All that mass compresses into a point with infinite density and zero volume, making even the smartest physicists throw up their hands. It's where temperatures and energies are off the charts crazy. Our current equations barely hold up against this cosmic anomaly, revealing that our understanding has limits. Essentially, general relativity chirps, "I can describe the journey there, but once you arrive, good luck figuring it out." So, as you tumble through the black hole, remember that you're not just embarking on a physical journey, but a profound journey through the very fabric of time and space itself. It's a dizzying reality check where the rules of existence twist into a nightmarish mime show and escape becomes merely a figment of imagination. The singularity isn't just a destination. It's a moment holding infinite mysteries waiting to be unraveled or forever lost in the cosmic dance of existence. Physicists have a wild hunch that cracking the code of quantum gravity, think of it as merging general relativity with quantum mechanics, might finally unveil the enigma of the singularity. This mysterious core of black holes, often thought to be just a point, could actually be something far more complex, like a region with a cosmic inner structure that's too advanced for our current understanding. For now, it's like a cosmic riddle wrapped in an enigma, waiting for an answer. Now, let's bust a myth. Black holes aren't the cosmic vacuum cleaners of the universe, ready to suck up everything in sight like a rogue Roomba on a rampage. Nope. They play by the same gravitational rules that apply to any big heavyweight in space. If we swapped the Sun for a black hole of equal mass, Earth wouldn't even flinch. It would still happily orbit like it always does. The gravitational pull relies on mass alone, whether it's a star or a sneaky black hole hiding out there. Of course, venture too close, and things get dicey. If you cross that invisible line, you're stepping into Danger Town, where gravity pulls harder than a toddler with a candy bar. At safe distances, black holes are just massive chillers in space, allowing objects to orbit them just like planets spin around stars. Matter only falls into these cosmic beasts when it loses energy and momentum, spiraling in slowly. From afar, they're more like the friendly giants of space. Let's not forget about the wild ride of tidal forces. When it comes to black holes, gravity gets a little dramatic. Picture an astronaut falling feet first into a stellar mass black hole. Their feet would get yanked down harder than a cat after a laser dot. This creates a gruesome phenomenon known as spaghettification, where immense tidal forces stretch that poor soul into a long, noodle-like strand, eventually tearing them apart at the atomic level. Ouch! But what about supermassive black holes? Surprisingly, as they get bigger, the tidal forces at their event horizons ease up. It's like crossing a gentle ocean wave instead of being slammed by a tsunami. For a black hole with a mass of 1 billion suns, you could glide across the event horizon without any immediate doom. Still, cross it, and you're playing a high-stakes game of cosmic dodgeball. There's no escaping the singularity once you're in the zone. It might sound counterintuitive, but it all boils down to size. The danger isn't just about total mass, it's how rapidly gravity changes over a short distance. Stellar mass black holes have a compact event horizon, so the tidal gradient is steep. In contrast, those supermassive ones sport event horizons that stretch across millions of kilometers, making for a gentler gradient. But remember, while that initial entrance may be less spine-chilling, the endgame remains bleak. Finally, let's chat about Hawking radiation. Yes, black holes aren't just cosmic vacuum cleaners, they also slowly evaporate over unfathomably long periods of time, emitting this radiation as they lose mass. So, while they seem like they're here to stay, time is a funny thing, even in the realm of black holes. They might rule the night sky now, but one day way down the line they'll fade away. Who knew black holes were such a paradox wrapped in a stellar enigma? In the mind-bending world of physics, the 1970s saw physicist Stephen Hawking drop a bombshell that turned our understanding of black holes upside down. Contrary to the long-standing belief that black holes are blacker than a raven's feathers, Hawking unveiled their hidden talent for emitting a faint glow known as Hawking radiation. This ingeniously bizarre radiation emanates from the squabbles of particle-antiparticle pairs, which perpetually pop in and out of existence in the vast vacuum of space. Picture the particles as cosmic duelists, where one sneaky particle flings itself into the black hole while its buddy escapes, giving the impression that the black hole is putting on a dazzling radiation show. But hold on to your telescopes. This dance of particles results in a far-reaching cosmic implication. Black holes are not eternal enclosures. Instead, they lose mass over incomprehensibly long periods, eventually leading them to evaporate, particularly for the mini black holes, if such rarities exist. Imagine a black hole chugging away on its long journey toward evaporation while our universe ages at the speed of molasses. For the colossal beasts of stellar origin, their gradual weight loss stretches far beyond the lifetime of our entire universe. Talk about a cosmic slow burn. Now, let's sprinkle in some temperature talk. Hawking radiation isn't just a cosmic show. It has a flair for irony. Smaller black holes are hotter and emit intense radiation, while their larger counterparts languish in the chill of near absolute zero. Picture this. A black hole weighing as much as the sun is practically freezing compared to the cosmic microwave background. Meanwhile, a hypothetical miniature black hole would be sizzling like a frying pan, radiating high-energy particles like a supernova at a summer barbecue. As our cosmic giants lose mass, something intriguing happens. The decline in weight cranks up their temperature, which, in turn, speeds up the evaporation process. It's like watching a black hole go into overdrive, leading to a dramatic finale, an explosive burst of radiation that could rival humanity's best fireworks display. But don't hold your breath just yet. For the heavyweight black holes out there, this exciting endgame won't unravel for trillions of years, plenty of time for the universe to grow cold and dark. But it doesn't end there. Meet the zippy black holes that spin faster than a toddler on a sugar rush. These slick cosmic entities are characterized by just three traits: mass, charge, and spin. Typically, their charge is negligible, leaving mass and spin to strut their stuff. As a black hole forms from a collapsing star, it inherits some of that star's rotation. Picture a spinning figure skater pulling their arms in. The collapsing core's spin accelerates, resulting in a fantastical spinning black hole that drags space-time along for the ride. And oh, the magic of frame dragging. Near these spinning black holes, space itself gets caught in their whirlpool, with everything including unsuspecting observers getting pulled along for the cosmic spin cycle. But wait, there's an even more fascinating twist. For those black holes on a spinning spree, an extra region emerges called the ergosphere, where remaining stationary is as tough as nailing jelly to a wall. In this energetic playground, space-time forces itself into a swirling dance that can turn observers' heads. Here comes the pièce de résistance, extracting energy from spinning black holes. Welcome to the ergosphere, where physicist Roger Penrose's brainchild known as the Penrose process takes center stage. By carefully dropping objects into this frenzied zone and allowing them to split into two, one piece can escape with a little more energy than it originally entered with, like a cosmic magician pulling a rabbit from a hat. And just like that, we tap into the rotational energy of a black hole, making it not just a mystical cosmic object, but a veritable energy treasure chest in the grand scheme of the universe. Imagine a far-off future where advanced civilizations harness the incredible power of spinning black holes. These cosmic whirlwinds might serve as energy sources, converting their rotational energy into something useful. It's mind-boggling to think that humans or beings far more advanced could tap into some of the universe's most energetic objects. Who wouldn't want to grab a cosmic cup of coffee brewed by a black hole spin? Talk about local traditions. Now, let's not forget about gravitational waves. These are imaginary ripples in the very fabric of space-time, caused by massive objects accelerating in the universe. When celestial heavyweights, like black holes, tango through space, they upset spacetime's calm like a clumsy dancer at a wedding, sending radiating waves out at the speed of light. While Einstein conceptualized these waves ages ago, we finally caught a glimpse of them in 2015, a cosmic moment that shook the scientific world. Black hole collisions are like the universe's heavy metal concerts, and they kick out a cacophony of gravitational waves. Picture two black holes spiraling around each other, reducing their dance floor as they radiate energy. The music gets louder, the waves grow thicker until, bam, they merge into a larger black hole and send shockwaves of gravitational energy that travel at the speed of light, transforming space-time itself as they go. Quite the show, eh? The grandest debutante of this cosmic ball happened on September 14, 2015. When the LIGO detectors picked up a shy little signal from a distant black hole merger. It lasted less than a second but packed a punch. Two black holes, each about 30 times the mass of our Sun, collided over 1 billion light-years away. Despite their distance, their ripples reached Earth, proving you don't need to be nearby to make an impact. The energy released was astonishingly greater than all the starlight in the observable universe combined. But wait, it gets better. This event confirmed Einstein's theories from a century ago and opened the floodgates for gravitational wave astronomy. Since that monumental day, dozens of black hole mergers have been detected, revealing vital secrets about these fascinating cosmic entities and the mysteries of space-time itself. Each merger dumps an incredible amount of energy into the gravitational wave cosmos like darkness swallowing a 1 billion light-year-long buffet of star power. If you thought energy release was impressive, hold on to your telescopes. During that initial event, around 3 solar masses worth of energy was emitted in less than a second. That's 3 suns worth of mass transformed into gravitational waves, momentarily outshining the entire observable universe. And yet, as incredible as it was, Earth felt nothing. These gravitational waves interact with matter like a gentle breeze across a summer field, barely noticeable, but evident to instruments that can see the subtle shifts. Now, let's dive into some speculation. For years, astronomical minds believed black holes came in 2 flavors: stellar mass, and supermassive. But what of the mysterious middle children? Enter the elusive intermediate mass black holes between hundreds and thousands of solar masses, those awkward yet fascinating cosmic teenagers. Residing in dense star clusters and hinted at through gravitational wave evidence, they represent a thrilling discovery waiting to happen, highlighting just how bewilderingly complex our universe remains. Buckle up, space enthusiasts. There's more to explore. Black holes have an air of mystery about their formation that keeps astronomers on their toes. Stellar collisions in densely packed regions might kickstart their birth, or perhaps they emerge when several stellar mass black holes merge into one. Intermediate mass black holes are the cosmic glue that could link all black hole sizes throughout history, hinting at how they might form gigantic cousins over billions of years. Talk about a family reunion on a galactic scale. Then there's the peculiar tale of primordial black holes, those rare cosmic critters that might have formed right after the Big Bang. As the universe exploded into existence, it was sizzling hot and densely packed, with tiny fluctuations leading some regions to collapse into black holes without bothering to create stars. These black holes come in surprising sizes, from tiny pebbles to thousands of solar masses. If they're out there, they've been hanging around since the universe was in its diaper. Diving deeper into cosmic mysteries, some physicists have a wild theory. What if primordial black holes account for dark matter, that elusive stuff that dominates our universe? To search for these sneaky objects, scientists employ creative techniques like gravitational lensing. While no primordial black holes have been confirmed yet, the idea keeps scientists buzzing with curiosity, like kids learning there might be a hidden passage in their favorite storybook. But black holes aren't just cosmic curiosities, they're like nature's ultimate laboratories, pushing the limits of physics. Their extreme conditions turn gravity, temperatures, and densities up to 11, far beyond what humankind can recreate on Earth. Physicists are buzzing with questions. Does general relativity hold its ground near a black hole's event horizon, or do things get wobbly? How do magnetic fields react in such gravitational pull? Each discovery surrounding black holes refines our understanding of the universe's fundamental mechanics. Einstein's theories open the door to some mind-bending possibilities, like wormholes' hypothetical shortcuts through space-time. Picture a cosmic tunnel linking two far-off locations. However, to keep such a wormhole stable, scientists propose the existence of exotic matter with negative energy, a concept that's still floating around without confirmation. Should a wormhole spring into existence, it'd likely collapse faster than you can say time travel, feeding our imaginations but staying firmly in the realm of hypothetical. And then there's the intriguing phenomenon known as the photon sphere, where light itself dances around a black hole. Situated just outside a non-rotating black hole's event horizon, this zone is where gravity plays a gravity-bending game. Photons can orbit endlessly, creating a cosmic merry-go-round for light. But it's a game of delicate balance. Even the slightest nudge can send a photon either spiraling toward oblivion or soaring away into the cosmos. For those peering into the abyss, the photon sphere transforms everyday perceptions into a wild optical extravaganza. Light from distant stars can loop around the black hole multiple times, distorting images till you wonder if you've just stepped into an artistic rendition of the universe. It acts as a boundary where light shifts from freedom to an eternal trap, showcasing the fanciful and bizarre nature of black holes and the playground of space they inhabit. Black holes are the universe's ultimate energy machines, outshining even the brightest stars. While nuclear fusion gets less than 1% of mass converted to energy, black holes are in a league of their own. Picture this: matter spirals into a black hole, twisting and turning like it's on a cosmic carnival ride. As it spirals, intense friction and magnetic forces crank up the heat so high that nearly 40% of the energy just zaps away before crossing the event horizon. Talk about a cosmic energy source. Quasars powered by supermassive black holes can shine brightly enough to light up entire galaxies. Yet, black holes aren't just energy superstars. They're like the universe's grand simplifiers. Enter the no-hair theorem, which asserts that black holes, despite their complex cosmic origin, are heartbreakingly simple. Imagine forming from an incredibly diverse star, only to end up with just 3 defining characteristics: mass, electric charge, and angular momentum. Forget the star's romantic past. Once it's a black hole, it's all about those three properties. If two black holes flaunt the same mass and spin, they're identical twins, whether they came from hydrogen, iron, or even elephants. Mind-blowing, right? But hold on to your stardust. This simplicity raises some serious eyebrows and a couple of existential crises. When matter falls into a black hole, it seems to lose all its unique backstory, sparking the infamous black hole information paradox. According to quantum mechanics, information shouldn't just vanish into the void. So, when cosmic debris gets sucked into a black hole, and the Hawking radiation that escapes carries no trace of this information, it's like a magic trick gone wrong. Where's the information hiding? This has left physicists scratching their heads and mixing metaphors for decades. The chase to resolve this cosmic riddle has led to some tantalizing theories. Some scientists propose that the information gets encoded in the subtle patterns of Hawking radiation, while others suggest it could be written on the event horizon itself, a concept known as the holographic principle. This concept is as wild as it sounds. All the secrets of what's happening in the black hole may be inscribed on its outer edge. Think of it like a cosmic movie, where everything happening inside is written in code on the surface. Speaking of the holographic principle, let's really get flabbergasted. The idea suggests that our entire three-dimensional universe could be a projection of data stored on a flat, two-dimensional surface. It's like casting a cosmic shadow. For black holes, the event horizon's surface area could limit how much information is held within. This mind-bending principle offers a fresh framework for tackling questions of quantum gravity and string theory. Just when you thought you understood the cosmos, it throws a hologram at you. But wait, there's more cosmic wonder. Some theories propose that not only do black holes simplify existence, they might create new universes at their centers. Imagine singularities connecting to entirely fresh realms of space-time. It's like cosmological real estate development on a grand, incomprehensible scale. If these singularities are portals to new dimensions, well, who knows? Perhaps there's a whole metaverse of universes swirling around in the dark folds of space-time, waiting for us to unravel. Now that's something to ponder while staring at the night sky. Imagine if every black hole we see swirling in the cosmos isn't just a cosmic vacuum, but a cosmic delivery system for new universes. Yes, you heard that right. According to some speculative theories, each black hole could give birth to a brand new universe, unfurling on the other side of its mysterious singularity. It's like the universe's version of a never-ending story, with each black hole marking an ending that could very well be a thrilling new beginning. Now let's have a look at how our universe might have sprouted from a black hole in some vast parent universe. This idea, while still hanging out on the fringes of science, offers a fascinating twist to the riddle of the Big Bang. Imagine all that chaos and hotness inside a black hole causing a bouncy baby universe to pop out. So, instead of collapsing into oblivion, these black holes could transform that dramatic cringe-worthy ending into an expansive and hopeful new chapter. Even more wild are the micro-black hole scientists speculate might be created in particle colliders. You know, little cosmic cuties that evaporate faster than you can say quantum gravity. When the Large Hadron Collider revved its engines, some folks dreamt of tiny black holes appearing, courtesy of those high-energy collisions. If they really exist, these mini black holes would be less massive than a grain of sand, posing zero risk to life on Earth. Talk about a harmless little cosmic experiment. But for the sake of fun, let's imagine these miniature black holes could actually exist for a teeny moment before evaporating. They'd be like shooting stars in the black hole world, brief but fascinating. According to Stephen Hawking, they wouldn't just vanish. They would also provide thrilling insights into subatomic dimensions. Despite all the safety assurances flying around, many scientists were sure that if such black holes formed, they'd be gone in the blink of an eye, long before they could mess with anything else. Now let's dive into a cheeky little idea: charged black holes. Most black holes are neutral, but thanks to the math gods of general relativity, we can imagine scenarios where a black hole could actually carry a charge. If it's rotating, you might end up with something called a Kerr black hole. Picture this. These bad boys could potentially exert electromagnetic forces along with their infamous gravitational pull. However, most of the time, they'd be looking pretty neutral as they orbit through the universe. Then there's the mind-bending concept of naked singularities, which are basically black holes that forgotten their cloaks. Unlike the shy, hidden singularities in standard black holes, these naughty entities would be out there for all to see. This idea sends shivers down the spine of physicists because it might break the laws of physics itself, which is where the cosmic censorship conjecture struts onto the stage. Proposed by Roger Penrose, this conjecture argues that nature wouldn't allow naked singularities to exist. But what if they do? If they were roaming around, they'd break the predictability of our universe, making it a chaotic carnival ride of unexplainable phenomena. As a safety net, the cosmic censorship conjecture aims to keep our universe predictable and orderly. Still, despite years of research, no naked singularities have ever been spotted. Physicists suspect they're often fiction, and something like quantum quirks prevents their creation, keeping our universe's wild side safely tucked away behind event horizons. For the rotating black holes, things get deliciously complicated. These celestial whirlwinds have both an inner and outer event horizon, making them the prima donnas of the black hole family. They boast a unique twist to the standard single event horizon setup that non-rotating black holes possess. It's all swirling around in the cosmic dance of gravity, electromagnetic forces, and time, leaving us staring at our telescopes, munching popcorn, and waiting to see just what these cosmic enigmas do next. The KUR solution introduces a fascinating twist to our understanding of black holes, presenting two distinct horizons, an outer event horizon and an inner caustic horizon. The outer horizon is still that dreaded one-way ticket to oblivion we've all heard about, but the inner horizon adds a layer of mystery. Beyond it, near the singularity, things get even wilder. Calculations hint at chaotic instabilities, making it dubious whether anything can bravely venture that far intact. Let's talk about the singularity itself. In a rotating black hole, it's suggested this mysterious center might resemble a ring rather than a simple point. This swirling feature adds even more pizzazz to the already mystifying world of rotating black holes. And if you think it couldn't get any crazier, time takes on a whole new meaning in these gravitational giants. It's like an extreme case of being fashionably late, where time near a black hole slows down dramatically. Now, imagine being the ultimate cosmic procrastinator, parking your spacecraft close to a massive black hole just outside that event horizon. While you're chilling there for a year, the universe could race ahead, slipping through decades or even centuries. This isn't just science fiction. The mathematical magic exists. It's the cosmic equivalent of time travel, where an adventurous astronaut could return home after taking a leisurely stroll across the ages. What a way to dodge those pesky mortgage payments. Of course, before you pack your bags for this little jaunt, there are some serious engineering hurdles. Surviving the marriage of immense gravitational forces, radiation, and debris is just the beginning. Plus, you'll need monstrous energy levels to break free from the black hole's pull upon your return. But hey, if the physics says it can be done, who are we to argue? Black holes, with their warped space-time, offer a tantalizing glimpse into the art of time travel that could redefine our journey through time. And here's a brain bender. Black holes don't obliterate matter, they transform it. The claim that matter is lost inside a black hole is a bit misleading. In reality, matter is reshaped beyond recognition, diving headfirst into the black hole's essence, contributing to its mass, charge, and spin. The complexity we know may vanish from view, but its gravitational influence stretches into the cosmos for eons. In a sense, black holes are the universe's redefinition artists, converting matter into a cosmic punchline. Got more time? Let's take a dive into the dynamic ecosystem surrounding black holes, accretion disks. When a black hole snags some hapless matter, it doesn't pull it in right away. Instead, that material starts swirling around in an accretion disk, radiating energy like a glowing halo. This dazzling display can persist long enough to light up the cosmic dance floor, depending on how much material continues to fuel the disk. It's like a never-ending party, but with a lot more radiation and significantly fewer dance moves. These accretion disks have been known to shine for millions, even billions of years. Supermassive black holes in the centers of galaxies might inhale stars or interstellar gas like snacks from a cosmic vending machine, feeding their radiant disks. And while some accretion disks flare up dramatically when new material arrives, they can just as easily cool down and fade when the buffet runs dry. It's a fitting reminder that even in the extreme cosmic scale, black holes contribute to the long, slow processes that shape galaxies beyond our wildest imaginings. Let's not forget about tidal disruption events. These enchanting cosmic calamities happen when innocent stars wander a bit too close to supermassive black holes, only to suffer the consequences. It's an outrageous game of celestial tug-of-war, reminding us that black holes are not just passive observers. They're incredibly dynamic players in the grand cosmic ballet, forever altering the theatrical galaxy around them. So, strap in and enjoy the ride, because black holes are far from being mere voids in space. They're vibrant, transformative entities, forever reshaping the cosmos. Occasionally, a star wanders too close to the supermassive black hole lurking at the center of a galaxy, and chaos ensues. The intense tidal forces overpower the star's self-gravity, inevitably ripping it apart and creating long, flowing streams of gas. As if on cue, part of this material takes a perilous plunge into the black hole, forming a temporary accretion disk, while the remnants get flung outward like cosmic confetti. This dramatic showdown, known as a tidal disruption event, leads to a brilliant light flare that can dazzle observers for months, even years. Who knew stars could put on such a dazzling final show? Astronomers have set their telescopes to catch these spectacular flares lighting up distant galaxies, shining a spotlight on moments when stars meet their cosmic doom. Each flare reveals critical tidbits about the mass and characteristics of the black holes involved, unveiling the epic chaos that reigns in their gravitational realms. It's wild to think that stars that have been orbiting comfortably for eons can swiftly find themselves in a fatal tango of destruction, the cosmic equivalent of stepping on a rickety stage and getting the boot. But wait, there's more. Sometimes, two black holes start twirling around each other in a cosmic dance, forming a spectacular binary system. This can happen when galaxies collide, bringing their central black holes together for an intergalactic jam session, or when two massive stars from a binary duo go out with a bang and collapse into black holes. As they will closer over the eons, they lose energy to gravitational waves, gracing the universe with a cosmic symphony that spirals down to an exhilarating finale, merging in a cataclysmic collision that's anything but subtle. Talk about a dramatic exit. During the grand finale, the newly formed black hole takes a moment to vibrate, settling into its new stable state while emitting a final burst of gravitational waves. These mergers not only add to the exciting cosmic event roster, but also help astronomers assemble clues about just how frequently these powerful collisions happen and how black holes have evolved throughout cosmic history. Who would have thought that cosmic matchmaking could be this thrilling? Speaking of cosmic spectacles, enter gravitational lensing, where black holes flex their massive muscles and bend light in jaw-dropping ways. When starlight passes near these black holes, their immense gravity warps the light's path like an optical funhouse mirror. If a distant star perfectly aligns, the light takes a wild ride around the black hole, creating multiple distorted images. Voila, an Einstein ring. The black hole remains a dark mystery, but it's surrounded by a dazzling halo of lensed light that could make anyone's head spin. Just imagine the sky transforming into a mesmerizing galactic optical illusion. If you were to plop down near a black hole, the night sky would transform into a whimsical masterpiece, with stars smeared and duplicated, creating a trippy vista right before your eyes. The event horizon would loom as a dark shadow against the dazzling backdrop of warped light. Crazy, right? Astronomers have watched these effects unfold in simulations, and the groundbreaking 2019 image of the black hole in M87 showcased a brilliant ring of light dancing around the event horizon, generated by this lensing phenomenon. Talk about cosmic visuals knocking our socks off. But when we talk about imaging a black hole, we're really petting a whole new idea. We're looking at the shadow of the black hole. This is the region where photons get caught in a gravitational trap before they can escape. For a black hole that doesn't spin, its shadow stretches out to around 2.6 times the radius of the event horizon. Imagine that! But thankfully, it's set against a glowing canvas often composed of accretion disks or surrounding gas, giving astronomers vital clues about black hole masses. The first ever black hole shadow was imaged from the supermassive black hole in galaxy M87, followed closely by Sagittarius A in our Milky Way. These observations not only validated predictions from general relativity, but also served up the first direct visual evidence of event horizons nothing like getting science to pop. Black holes turn the traditional ideas of time and causality on their heads. Inside their event horizons, the lines between time and space curve and twist in ways that would make even the most seasoned time traveler dizzy. The singularity, that enigmatic heart of a black hole, isn't a location in the cosmos you can point to on a star map, but rather a peculiar moment where everything gets funneled. Inside these gravitational beasts, it's like a cosmic game of Where's Waldo? Except Waldo is time, and he's hopelessly lost. Imagine peeking into a black hole and seeing things freeze right at the edge. For you, the onlooker, it's a stunning, albeit slightly unnerving view, where the object appears to solemnly stand still as it reaches that fateful horizon. Meanwhile, for the sunlight switcheroo going on in the black hole, the infalling object is still partying, oblivious to the cosmic spectacle. Einstein really outdid himself here by proving that time is as flexible as a yoga master twisted and intertwined with the observer's experience. When you think of black holes, it's like stepping into a dark, mysterious club that operates on a secret guest list. Most of these enigmatic entities are practically invisible, lurking quietly, waiting for the right moment to strut their gravitational stuff. The Milky Way is probably overflowing with these silent giants, estimated to house tens of millions of stellar mass black holes. Yet, most of us would only be able to spot a few dozen through our high-tech telescopes. They typically come out to play when someone else is around, stealing gas from a buddy star. There are nifty tricks astronomers use to uncover these elusive dancers in the dark, such as gravitational wave astronomy. It's a bit like eavesdropping on a cosmic conversation when black holes merge while gravitational microlensing acts as a cosmic paparazzi, catching brief glimpses of a black hole as it magnifies a background star. Each technological advancement feels like upgrading from flip phones to smart devices, with new discoveries on the horizon. Before you know it, we'll be discovering an entire black hole society operating behind our backs. Now, let's talk size. Black holes come in all shapes and sizes, from the tiny to the gargantuan. There's even a theoretical Planck mass black hole, weighing just about 22 micrograms, back from its micro-vacation in cosmic history. These pint-sized anomalies wouldn't last more than a blink of an eye, evaporating thanks to the quirky phenomenon known as Hawking radiation. As for the big boys, we're talking monsters lurking at the galaxy's center, weighing in like 10 billion suns on a cosmic diet with a penchant for gravitationally munching on stars. In a galaxy scattered with these fascinating entities, black holes are not the rare gems we might think they are. Nature has been busy churning out these gravitational wonders across a massive scale, from stellar black holes that typically weigh several solar masses to the supermassive giants reaching into the billions. This variety showcases how black holes are simply nature's way of keeping things spicy and diverse in the cosmos. If you think it's a drag living in a neighborhood with one black hole, consider this: the closest known black hole might be just around the corner. Initially pegged at a mere 1,000 light-years away, the nearest black hole, called HR 6819, had a little cosmic drama unfold with its status. For now, it appears that the confirmed stellar mass black hole is still out there, roaming farther off. And let's not forget our own galactic heavyweight, Sagittarius A, which is chilling about 26,000 light-years from our cosmic crib. The search continues, making it feel like a galactic treasure hunt with only a hint of an existential crisis. In the vast darkness of the cosmos, closer black holes are silently cruising around, just out of our sight. Picture them as shadows tucked neatly in the night sky, residing in the galactic club of celestial mysteries. They've been here longer than any of the stars, enduring like that old dancing partner who refuses to leave the floor. Once formed, these cosmic heavyweights hang around for eternity, way longer than a human lifespan or even the age of the universe itself. Imagine waiting 1067 years for a stellar black hole to vanish. That's a patience level most of us can only dream about. While planets may grow cold and galaxies drift apart, black holes remain steadfast, looming like cosmic foghorns in the void. They're practically the universe's nostalgic tabby cat, watching as everything else fades away. A time will arrive when black holes will be among the last structures left, astronautically melting into oblivion while the rest of the universe moves on to a new chapter. They are truly the ultimate survivors, quiet witnesses to everything like a timeless storyteller. Only their tales involve cosmic destruction and dimensional distortions. And let's not forget, black holes aren't just dark enigma friends either. These cosmic celebrities are vital to our understanding of space-time. They poke and prod at the fundamental laws of physics, forcing scientists to take a closer look at both gravity and quantum mechanics. With every observation, whether it's through gravitational waves or direct imaging, scientists get new hints about the cosmic puzzle. Black holes become our cosmic labs, allowing us to experiment with questions that even the most imaginative sci-fi novels haven't touched upon. On the forefront of physicists' minds is that elusive dream of quantum gravity, a theory that unites quantum mechanics with general relativity. Black holes are like the main event at the theoretical physics wrestling match, where the largest mass meets the smallest scale. At their singularities, the rules seem to bend and twist into mind-boggling shapes. It's the cosmic rollercoaster nobody dares to ride, yet we keep staring at it in awe from a safe distance. As folks dive deeper into the black hole rabbit hole, they stumble upon the infamous black hole information paradox. This dilemma questions the very fabric of reality, challenging our notions of information and causality. Think of it as the ultimate cosmic riddle. It's like trying to solve for X in algebra after being thrown into a whirlpool of string theory and loop quantum gravity. Each proposed solution just presents more mysteries to unravel, yet black holes remain steadfast in their quest for answers. Visualizing the insides of a black hole, though? Now that's an exercise in futility. Our daily lives are anchored in familiar experiences, but the moment we try to picture what lies within a black hole, our brains hit a wall. Picture trying to capture the taste of sunshine or the sound of a rainbow. Yep, it's that kind of impossible. Yet, despite all the wild theories and paradoxes, we know they exist and operate under the same laws that govern the universe, just cranked up to the max. In a universe filled with spectacular oddities, black holes remind us that there's a whole lot more out there than what we can perceive. This duality reveals the truth that shines beyond our comprehension. They stand as a reminder that reality stretches far out into the vast unknown, where only the abstract elegance of mathematics and the rigor of physics can lead. It's a delightful twist that brings us back to ancient philosophers, who, long before Einstein, mused about the existence of such enigmatic celestial bodies dark, dense, and utterly mind-blowing. In the 18th century, two imaginative minds, John Maxwell and Pierre Simon Lelis, came up with the idea of dark stars, cosmic giants with such intense gravity that not even light could escape their clutches. Though they were operating under Sir Isaac Newton's physics, way ahead of its time, their intuition about these elusive entities was spot on. Little did they know, their musings about dark stars were a precursor to the modern concept of black holes, over a century before anyone had a clue about them. Talk about foresight. These early thoughts serve as a reminder that science is an ever-evolving journey, with each generation standing on the shoulders of giants. In fact, their theories, while not perfect, were crucial for nurturing our current understanding of black holes. They open the doors to the mind-blowing idea that certain cosmic phenomena aren't just mysterious objects, they could very well represent the limits of our space-time. Think of it as the universe saying, this is where space and time decide to take a coffee break. Now, let's set the record straight. Black holes are often romanticized in science fiction as gateways to alternate dimensions, but they're actually the final destinations rather than travel hubs. Imagine cruising through space, only to discover that crossing the event horizon is the cosmic equivalent of hitting a dead end. Once you plummet into that gravitational abyss, your journey concludes at a singularity. It's the ultimate cosmic trap, where all the known laws of physics wave a white flag, making it one heck of a party that nobody can leave. Speaking of epic parties, When merging black holes collide, the symphony of gravitational waves they emit can be transformed into sound. This is where scientists at LIGO come into play, translating gravitational waves into audio clips, giving us a chirp that rises and falls like an interstellar roller coaster. Each merger creates a unique sound depending on the black hole's masses and spins, inviting us to a cosmic concert that's all about invisible ripples in the fabric of space-time. Who knew the universe could throw such a rocking shindig? As we contemplate the nature of black holes, they also hold fascinating clues about the universe's ultimate fate. If the cosmos keeps expanding, things are destined for a slow, dark decline in a scenario dubbed the Big Freeze. Picture a future where black holes are the last holdouts of structure, drifting in an ever-widening void, until they, too, fade away via the enigmatic process of Hawking radiation, a process that's as mystifying as it sounds. Eventually, all that will be left are mere particles and radiation, with the whole shebang ending in a grand cosmic nothing to see here, folks. These black holes are the ultimate grand finale in the universe's drama, witnessing almost everything that has ever transpired. It's like they're the last remaining characters in a play that has unfolded over billions of years. Yet, some scientists are now pondering if these dark cosmic entities might even be candidates for dark matter, the mysterious stuff that makes up most of the universe's mass, yet refuses to show its face. Could black holes be hiding out there, silently holding the universe's secrets among their shadows? The allure of black holes not only lies in their enigmatic nature, but also in what they might reveal about the cosmos. These incredible formations are more than just cosmic leftovers. They're the theorizers of existence wrapped in an endless enigma. As we journey onward, exploring the mysteries of the universe, it's clear that black holes are not just a chapter but a captivating saga within the grand narrative of existence itself. Primordial black holes are intriguing little cosmic nuggets that might have formed during the early universe. These minuscule wonders are quite the elusive critters. Spotting them directly is like trying to catch smoke with your bare hands. Although gravitational lensing and indirect methods can help us pin down their numbers, current evidence suggests they can't possibly account for all dark matter. Still, they could be a charming component of the elusive dark matter puzzle, sparking scientists' imaginations since they rely on good old physics instead of some far-fetched hypothetical particles. However, physicists mostly lean towards the particle theory for explaining dark matter, relegating black holes to the sidelines. The debate is more vibrant than a college dorm on a Friday night, with ongoing searches fueling the quest for a clearer understanding of dark matter. The question continues to hover above us like a cosmic rain cloud. What, exactly, is dark matter? It's like a never-ending sitcom, with new episodes unveiling every twist and turn in our comprehension of the universe. Now, let's take a moment and imagine the chaotic beauty of getting up close and personal with a black hole. With such extreme gravitational forces at play, light doesn't just pass by. It warps into rings and arcs of dazzling distortion. Observers would see the sky do a breathtaking tango, with stars shifting positions in a cosmic game of musical chairs. Instead of a peaceful constellation map, you'd get a mind-bending swirl of lights playing around a dark disk, the event horizon, where light goes to die but occasionally takes a joyful spin around the block before fleeing. If the black hole is spinning, things get even wilder thanks to frame dragging effects. Picture a local universe where space acts like silly putty, stretched, folded, and reformed. Visiting such a place hypothetically, of course, would be genuinely disorienting, reminding us that space isn't just a backdrop. It's a living, breathing canvas shaped by mass and energy. Black holes push the edges of reality and prompt existential musings about the fabric of our universe and the nature of existence itself. These cosmic mysteries also lead us to ponder the philosophical depths surrounding black holes. What's the deal with time near these enigmatic objects? Can information really be obliterated? If something is tucked away behind an event horizon, does it even exist? The interplay between science and metaphysics begins here, weaving a tale that entices philosophers as much as physicists. We scratch our heads, wondering how to know what lies inside a black hole, questioning the very limits of our understanding. Black holes serve as both relics and engines in the grand drama of cosmic history. Each one has its own backstory, From the stellar mass black holes birthed from the spectacular explosions of massive stars to supermassive black holes that have grown alongside galaxies in a breathtaking dance over billions of years. Intermediate mass black holes hint at the secrets waiting to be uncovered in dense stellar clusters or primordial universe sketches, each a chapter in the epic narrative of existence. As we engage with the mysteries of black holes, we are drawn into a whirlwind of curiosity that keeps our collective imaginations running rampant. They hang like dark sentinels in the vast cosmos, inviting us to explore the strange and beautiful intricacies of existence. So, let's keep our eyes on these cosmic enigmas and embrace the delightful chaos of discovery, because just like a captivating book, the saga of black holes is far from over. Black holes are the universe's heavyweights, embodying cosmic endings and beginnings all at once. As we peer into their mysterious depths, we find a thrilling narrative that chronicles how stars meet their fiery demise and how galaxies morph over eons. They aren't mere side notes in the story of the cosmos. Rather, they take center stage, shaping the universe's history like a dramatic play where destruction paves the way for new creations. Isn't it wild to think that these enigmatic entities are, in fact, the authors of cosmic tales? What's even crazier is that black holes, with their terrifying reputation, actually follow some pretty straightforward rules. They're not the chaotic monsters some might envision. Instead, they are grounded in Einstein's equations, adhering to principles of thermodynamics and quantum mechanics. This predictability is like a warm cosmic hug, reminding us that despite the universe's chaos, there's a method to the madness. Our small, earthbound minds have the incredible ability to make sense of phenomena billions of light years away, a testament to human knowledge and curiosity. Observing these celestial giants isn't a solo endeavor. It's more like a global jam session where scientists from all corners of the world come together. Just think about the Event Horizon Telescope. It's not just one big telescope, but a network of radio telescopes sprinkled across continents Hawaii to Antarctica, all working in harmony to create an Earth-sized eye on the sky. Synchronizing atomic clocks and shuffling data takes years of camaraderie and brainpower, underlining the idea that when it comes to black holes, no nation or individual can go it alone. The cosmos demands teamwork. The future of black hole research is looking brighter than ever. Soon, we'll have new, souped-up gravitational wave detectors that'll be able to spy on mergers happening in the farthest reaches of space with remarkable precision. Wave-chasing satellites like LISA are set to grace our skies in the 2030s, unveiling gravitational whispers from supermassive black holes that ground-based instruments can't pick up. With upgraded radio telescopes honing in on black hole formations, we're on the brink of charting their dynamics like never before. A vibrant era of cosmic exploration awaits. Let's not forget the cyclical nature of black holes. What looks like an end could be a brand new beginning in disguise. A star collapses in a grand supernova, and voila, a black hole is born. As time ticks by, these mysterious entities can kick off stellar births and help glue galaxies together. Eventually, as they dissipate, they release energy back into the universe like a cosmic recycle bin. It's a brilliant transformation where nothing truly vanishes but continuously shifts into new manifestations. Even in their darkest corners, black holes add flavor to the cosmic tableau. They refute the notion that anything can be a complete void. They're restless movers, involved in a dance of creation and destruction. The cycle of matter and energy reshaping itself demonstrates the universe's inherent dynamism. So next time you gaze at the night sky, remember that black holes are more than just shrinking sources of gravity. They're vibrant storytellers weaving the tale of existence itself. Endings and beginnings are like twins separated at birth, yet they're intricately woven together in the fabric of space-time. The enigmatic study of black holes showcases humanity's relentless curiosity and audacity. Imagine diving headfirst into thought-provoking galaxies far removed from the mundane, where abstract math and mind-bending physics dance in a cosmic ballet. It's no stroll in the park, but the thrill of building hypersensitive instruments and sifting through colossal data sets. We do this heroic work motivated by our insatiable thirst for knowledge. Consider this. We've caught whispers of merging black holes frolicking a billion light years away, and we've even snapped photos of their event horizons. That's right, we've gazed into the depths of our own galaxy and beheld the unseen. This endeavor is more than just a delightful romp in the realm of science, it's a declaration of our humanity. We are explorers at heart, gazing upward with childlike wonder and rejecting the mystery of existence without a thorough investigation. In the cosmic theater, black holes are the silent stars waiting their turn. They don't shout or emit dazzling light. Instead, they are the Zen masters of the universe, patient, omnipresent, subtly reshaping the space around them through gravity alone. Some gallivant in cosmic corners, having bided their time for billions of years, while others are newbies still wobbling from their explosive beginnings. These ominous gravitational beasts linger everywhere in the core of galaxies and in the voids between stars, both unseen and surreal, waiting for curious minds to unravel their mysteries. And oh, do black holes have secrets? They unlock enigmas about reality, time, and existence itself. In their shrouded silence, they speak volumes, illuminating profound questions we dare to ponder. The universe operates on unfathomable scales, millions and billions of solar masses compacted into regions tinier than our own solar system. This staggering vastness nudges our brains into overdrive, making us stretch our comprehension like a rubber band. To explore them, we lean heavily on mathematic wizardry and indirect observations, veering far from our earthly experiences. Yet, despite the cosmic distance and the inability to dabble within their event horizons, we grasp concepts from the shadows cast by black holes. This marvelous interplay between experience and understanding is one of science's most remarkable tricks. We push against our sensory limits with ingeniously crafted tools, simultaneously expanding our intuition through groundbreaking theories, bridging the gulf between us and the realities lurking just beyond our reach. The tale of black hole discovery stretches through history like a colorful tapestry, each thread representing human thought stretching back centuries. From whispers of dark stars to Einstein's revolutionary ideas and the glittering genius of Hawking's radiation, black holes are woven into the narrative of physics. Each generation has contributed to this cosmic puzzle, some ideas tangled in time and others shining bright, leading to fierce debates while gradually honing our comprehension of these enigmatic entities. Today, making predictions about black holes isn't a shot in the dark. We methodically observe and measure these cosmic marvels, testing the limits of our deepest theories about reality. The journey from hypothesis to cold hard fact underscores the power of the scientific method and the incredible collective achievement of human knowledge. As we continue our exploration, black holes keep surfacing within nearly every massive galaxy we scrutinize, revealing a celestial pattern that hints at something grander still yet to be discovered. Every colossal galaxy twinkles with a supermassive black hole nestled snugly at its heart, like the cherry on a cosmic sundae. This isn't just a random occurrence. The mass of these black holes is closely linked to the characteristics of their galaxies. Think of it as a cosmic partnership. These black holes are not merely the universe's dark, fluffy surprises, but are crucial players in the evolution of galaxies. They might even be the cosmic traffic cops, controlling star formation by heating up gas with their jets and winds. When galaxies get cozy and merge, their central black holes are expected to twirl together. Picture a dance-off that lasts for millions of years. As these behemoths form a binary system, they orbit each other, but catching a glimpse of this cosmic duet isn't easy. The astronomical timeline stretches out like a very long queue, and the separation between these black holes is like a game of hide and seek on a cosmic scale. Yet, fearless astronomers have found potential candidates, some of which flaunt quirky brightness patterns and other unusual jet structures, signaling that something is stirring in their orbital dance. As technology marches on, gravitational wave observatories like LISA have formally entered the party. They are all set to witness those dramatic final mergers of supermassive black holes, a cosmic spectacle that promises to reveal more about how galaxies collide and evolve over time. Each detection will be like unwrapping a cosmic gift, uncovering the secrets of galaxy mergers and illuminating how these central black holes grow through the vast, rich tapestry of the universe. But hold on, what if we encounter naked singularities? These cosmic oddities are like the wild cards of the universe, where the laws of physics might go haywire. The cosmic censorship hypothesis, introduced by the brilliant Roger Penrose, acts like a protective shield. It suggests that singularities are always veiled behind event horizons, keeping the chaos from spilling into the universe. While it hasn't been proven yet, this idea offers a comforting thought. The universe, with all its weirdness, remains fundamentally knowable, with cause and effect tethered firmly in place. Diving deeper, physicists are pondering what really happens at the centers of these black holes. Classical general relativity paints a picture of infinite density, but many suspect this might be a glitch in the theory. Enter the realm of quantum mechanics, where space-time itself performs a little dance. Some theories, like loop quantum gravity, hint that instead of a singularity, we might see an incredibly high yet finite curvature vibrating at the tiniest scales. Others suggest that all the secrets of the collapsing matter could be woven into delicate quantum correlations. String theory, with all its curious twists, adds even more flavors into the cosmic stew. It teases possibilities like fuzzballs, where the event horizon is brimming with quantum strings, stirring up a whole new realm of ideas. These theories are still bubbling away in the speculative pot, awaiting a complete recipe for quantum gravity. However, a recurring theme emerges. The singularity might just wave goodbye in the final act of our universe's grand narrative. Reflecting on time, black holes also serve as potential markers of its flow. Time, that relentless river rushing from past to future, is strangely linked to entropy, the measure of chaos in the universe. Thanks to the groundbreaking work of Jacob Bekenstein and Stephen Hawking, we know that black holes come with their own hefty dose of entropy, proportional to the area of their event horizons. This suggests that black holes are among the universe's most messy scenarios, and when they gobble up matter, the overall entropy of the universe takes a roller coaster ride upward. As black holes gracefully evaporate via Hawking radiation, they're like cosmic kilns releasing a little entropy confetti back into space. This fascinating intersection between black hole entropy and thermodynamics opens a door to the wonders of gravity, quantum mechanics, and even the elusive flow of time. Understanding these connections gives us juicy clues about why time marches forward with a distinct arrow and how our universe morphed from a primordial low-entropy state into the chaotic, high-energy cosmos we see today. Peering into a black hole's properties is like flipping through the pages of its cosmic diary. According to the no-hair theorem, these dark behemoths have just three simple traits: mass, spin, and charge. However, these traits are what tell their unpredictably dramatic stories. For instance, a rapidly spinning black hole hints at its origins from a twirling stellar parent or methodically collecting matter over time. On the flip side, a slow spinner might be the result of a chaotic game of cosmic bumper cars, merging from all directions. Now, let's talk size. And oh boy, these black holes can pack quite the punch. Supermassive black holes, boasting billions of solar masses, have been on an insatiable cosmic diet for eons, gobbling up gas, dust, and stars without a care in the universe. Each black hole is a time capsule tainted with tales of cosmic violence and evolution. By examining their individual quirks across various black holes, astronomers effectively piece together the elaborate history of galaxies, star formation, and the grand architecture of our universe. But here's the kicker: black holes force us to rethink existence itself. Picture a black hole born eons ago. The matter that birthed it has long since plunged past the event horizon, camouflaged from the outside world. So, the big question looms: does that matter still exist? To the rest of the universe, it's a mere whisper in the gravitational field. If something slips into the void and remains forever hidden, does it retain any meaningful existence? Modern physics argues that some trace of information persists, etched within the Hawking radiation or clinging to the memory of the event horizon. And just when you thought things couldn't get weirder, consider the extreme temperatures lurking inside black holes. As you inch closer to the singularity, tidal forces balloon until they become monstrous, shredding everything to bits and heating it beyond imagination. Near this cosmic abyss, space-time curvature twists and turns in ways that would make the well-established concepts of hot and cold spin out of control. Without a stable frame of reference, we might as well be speaking Martian about temperature. Expect black holes to outlive everything else in the universe. Yes, even after the last star flickers out and planetary systems fade into oblivion, these indomitable giants will linger on. In a chilly, dark future, where time stretches out longer than eternity itself, they will reign supreme. The petite black holes will twinkle out in about 1,067 years, while the mammoth supermassive ones will stubbornly hold their ground for over 10,100 years. Just think about it. Long after we're but stardust, black holes will be the last guardians of cosmic history. In the distant future, the universe will be eerily quiet, almost like the last gasps of a forgotten party. Black holes will become the last witnesses of cosmic drama, with each one slowly evaporating into nothingness. As they dissolve, they'll leave behind a thin soup of particles, drifting through an ever-expanding void. Picture it, a cosmic graveyard, where the only remnants of grand structures are these mysteriously evaporating giants, hinting at the universe's once boisterous past. Now imagine life hanging on the edge, literally. It's a wild thought, but could life exist near a black hole? Sure, it's an extreme habitat, with radiation levels that could fry bacon in a heartbeat and tidal forces strong enough to turn you into a spaghetti strand. Yet, if you dare to venture outwards, there might be places where conditions are a bit more hospitable. A planet dancing at a safe distance from a supermassive black hole could create its own cozy atmosphere, glowing gently from the warmth of the black hole's accretion disk instead of a distant star. Life on such a planet would come with its quirks. While they may experience time differently, like a cosmic version of a slow cooker, everything would feel perfectly normal in their own little bubble. They wouldn't be clamoring for a fast-paced lifestyle. Instead, they'd bask in the stability of their oddball environment. Plus, energy harvesting from the spinning black hole could provide a rather unique power source, keeping the lights on in an otherwise dark universe, reminding us that sometimes danger comes wrapped in alluring opportunities. Delving into black holes isn't merely a thrilling topic for bar conversations. It's a realm of beautiful mathematics. The equations describing these cosmic mysteries involve tensor calculus and differential geometry. Consider it physics nerd poetry. The simplicity of the Schwarzschild solution stands out, striking a balance between complexity and elegance while describing an extreme object. The Kerr solution for rotating black holes is like a complicated dance, intricate yet stunningly accurate, revealing the hidden symmetries of the universe while teasing out the mysteries of gravity and space-time. What's more fascinating is how black holes knit together various threads of physics. They emerge as the common ground for concepts ranging from general relativity to thermodynamics, linking them through curious phenomena like black hole entropy. They even flirt with quantum mechanics through the enigmatic Hawking radiation. Like a cosmic social club, these black holes welcome multitudes of ideas, making them a central hub in modern theoretical physics. Discussions around them bring together ideas that often seem worlds apart, all in the name of understanding the deepest secrets of our universe. The moment the Event Horizon Telescope presented the first glimpse of a black hole's shadow was nothing short of a sci-fi blockbuster come to life. In April 2019, the world collectively gasped as M87's black hole made its debut. It took the combined efforts of telescopes around the globe, acting like one massive observatory to capture what had long been theoretical. The image revealed a stunning ring of light, eerily framing a pitch-black center just as anticipated, powerful proof of black holes lurking in the cosmic shadows. The endeavor to capture that blurry, world-altering image involved teamwork tighter than the most synchronized dance crew. Using atomic clocks for precision and hauling petabytes of data for processing, it's like science's version of an epic heist movie. With advanced algorithms piecing together this cosmic puzzle, the result might have been a bit fuzzy, but it was a triumph nonetheless. It confirmed that black holes are as real as your neighbor's noisy lawnmower, and Einstein's equations hold strong, even when confronting the universe's wildest enigmas. What a testament to human curiosity and our relentless quest for the unknown. The second image of Sagittarius A, our galaxy's black hole, was no walk in the park. Although this cosmic giant is our neighbor compared to M87's black hole, it's like comparing a kitten to a lion in terms of mass. The accretion disk around Sagittarius A dances and fluctuates in a matter of minutes instead of languishing for days. As astronomers tried to capture this flickering spectacle, they realized they had to embrace new techniques to keep up with the cosmic chaos. After hours of keen observation, They managed to synthesize an extraordinary image in May 2022, and lo and behold, it bore a striking resemblance to M87's infamous ring. This was huge, the proof that our very own galactic heart harbors a massive black hole, marking an exhilarating moment for astronomers. The thrill of spotting the shadow of Sagittarius A felt like a sneak peek into our home, adding an air of intimacy to this monumental discovery. Black holes are the stars of their own ongoing research saga, with astronomers constantly on the hunt for new ones while also examining the known culprits. Gravitational wave physicists are in the mix, analyzing the grand fireworks of merging black holes, while theoretical physicists tackle burning questions about quantum gravity and those mind-bending singularities. Add numerical relativists who simulate cosmic collisions on supercomputers, and you have a full house of talent, all working to connect the dots of this vast cosmic jigsaw puzzle. The atmosphere at black hole conferences is a hub of excitement and collaboration, with brilliant minds sharing ideas across all domains. The vibrant tapestry of black hole research continues to blossom, thanks to fresh discoveries and theoretical insights. Even a century after black holes first popped onto the scientific radar, it's evident that there's still so much left to unravel. Humility rings true in the realm of these cosmic enigmas. Black holes keep us grounded, reminding us of our perceptual limits. Our senses are well tuned to the earthly delights of light, sound, and heat. But black holes challenge us. They're silent cosmic monsters that emit none of the usual signals we're equipped to detect. To peer into their depths, we must build instruments like radio telescopes and gravitational wave detectors that act as extensions of our senses, bridging that gap of understanding with pure science. This intricate dance of instruments and theories is how modern science thrives. Black holes take center stage in this elaborate game, revealing that the universe doesn't care about our limitations. Cosmic secrets lie just beyond the reach of our senses, beckoning to anyone willing to venture outside the confines of direct perception. Only those seeking knowledge from the mysteries of the cosmos can hope to decipher its hidden truths. The cosmic web connects black holes like a sprawling network of nodes, debunking the idea that galaxies float alone in the universe. Instead, think of them as part of a grand orchestra, with gas flowing along filaments, feeding into galactic appetites. When galaxies collide, their black holes might merge or even get kicked out into intergalactic oblivion, showcasing how the gravitational pull of these dark entities shapes the overarching blueprint of the universe. Every black hole tells a story that's interwoven into the cosmic saga, from the Big Bang to countless future tales. The realm of fiction has taken black holes on some wild rides too, from scientifically nuanced journeys to absolutely fanciful escapades. Science fiction has playfully spun black holes into portals, weapons, or head-scratching enigmas, some even crafted in collaboration with physicists for that touch of realism. These portrayals might walk the line of accuracy, but they ignite curiosity and wonder, inspiring a generation willing to grasp the general enigma of black holes and the broader universe we call home. Many physicists can trace their lifelong obsession with black holes back to childhood adventures in the realm of science fiction. It's a captivating dance where fiction meets science, each stepping on the other's toes in a delightful partner swap. Fiction asks that burning question, what if? While science nods and replies with a firm, here's what actually happens, and before you know it, new stories and theories spring into existence. In reality, black holes aren't mistakes or cosmic bloopers. They're bona fide byproducts born from the laws of our universe. Picture this, a colossal star, just hanging out, minding its own business, gets a little too heavy for its own good. In this grand cosmic performance, gravity takes the starring role, leading to a dramatic collapse. Black holes emerge as inevitable celebrities on the galactic stage, popping up whenever matter can't withstand the pressure. These celestial phenomena are vital, regulating galaxy growth, recycling cosmic materials, or perhaps serving some secret purpose that remains a mystery, waiting for a curious mind to decode. It's a bit mind-bending, but to fully grasp the cosmos, we've got to make peace with black holes. They're woven into the tapestry of existence, alongside stars and planets. As each new generation of scientists ventures into this inquiry, fresh theories sprout like weeds after a good rain. Young scientists stroll into lecture halls, armed with black holes as established fact, but their curiosity pushes them to ask deeper questions. How do these cosmic giants form? What lays beyond their mysterious singularities? And how do they tie into the fabric of quantum gravity? Each discovery sets off further intrigue. It's a relentless cycle of intellectual adventure. As the years roll on, black hole research promises to keep scholars busy for eons. Who knows? Young minds today could be the ones who crack the baffling information paradox or finally lay eyes on the first primordial black hole. Excitement buzzes in labs, where cutting-edge instruments peel back the layers of cosmic mystery with the grace of a skilled magician revealing their final trick. The thirst for knowledge about black holes is boundless, transforming them from mere scientific curiosities into grand mysteries steadfast before us. But aren't black holes more than just sophisticated scientific anomalies? Absolutely. They've wriggled their way into the cultural zeitgeist, becoming emblematic of the unknown, nestled in art, music, literature, and philosophy. They resonate with a part of us that remains captivated by the idea of boundaries and endings, where the familiar meets the alien. It's as if these enigmatic voids are mirrors reflecting our most profound fears and hopes about existence, a tangible representation of the cosmic questions that linger in our minds. When you find yourself hovering near a black hole, the silence carries a weight that feels almost spiritual. Airless and void-filled, the absence of sound becomes an eerie symphony of solitude. You may find yourself surrounded by nothing but the faint radiance of an accretion disk or the warped glow of stars, creating a juxtaposition between serene stillness and the chaos of the cosmos. It's like standing at the edge of infinity with only your heartbeat and spacecraft's hum for company, an invitation to think, reflect, and feel the universe's weight. In the mind's eye, one might imagine black holes as ravenous beasts, eternally devouring their surroundings. However, these cosmic entities are simply not wired for desire. They don't have a taste for destruction. They exist without motive. It's a matter-of-fact presence woven into the cosmic fabric, fascinating and aloof, nothing more than a manifestation of gravity's call. In the grand cosmic scheme, black holes shine not just as scientific entities but as awe-inspiring wonders, endlessly inviting us to delve deeper into the mysteries of existence. Black holes, those enigmatic creatures of the cosmic ocean, are not alive, nor do they harbor any malicious intent. They are mere concentrations of mass, following the cold laws of physics to warp space-time around them. Matter doesn't tumble into a black hole because it has been beckoned by a spooky invitation. It's simply obeying the unyielding force of gravity. When we talk about black holes feeding or growing, we're indulging in metaphorical speak. It's shorthand for a reality that is both stark and awe-inspiring. The concept of time becomes quite the mind-boggler within the realm of a black hole. What does time even mean when every finite path leads to the ominously dubbed singularity? As we descend past the event horizon, space and time perform a dramatic role reversal. It's not merely a spatial journey, but a one-way ticket on the time train to doom. Forget gliding through space. You're time traveling straight into the heart of gravity's dark embrace. Our intuitive understanding of time crumples like old paper, challenging us to rethink what we fundamentally believe. Explaining black holes requires us to toss out familiar notions and embrace the abstract marvel of space-time unveiled in Einstein's equations. In this peculiar space, traditional language fumbles. The mathematics of black holes and the diagrams that encapsulate their behavior often say infinitely more than mere words ever could. It's a cerebral playground where the very nature of time waits to be unraveled, leaving humans in delightful confusion and awe at the relationship between gravity and eternity. Fast forward to a future where humanity might harness black holes as cosmic energy farms or gravitational anchors. If we can stretch our imagination, it's exciting to ponder how future civilizations could tap into the rotational energy via something called the Penrose process. Imagine vast stations powered by matter swirling into an accretion disk, or using those formidable gravitational fields for time dilation, enabling wild relativistic voyages deeper into the future. Black holes, dangerous as they may be, could transform into invaluable tools for the ambitious minds of tomorrow. While these ideas seem like science fiction today, they remind us that black holes could be more than just deadly pits of despair. With the proper progression in technology and a sprinkle of bravery, we might exploit their mysterious properties for the greater good. However, let's keep it real. Taming such cosmic giants would demand advancements beyond our wildest dreams, not to mention the risks involved. The promise of turning peril into potential is tantalizing, don't you think? Yet, amidst all the fascination, we met our greatest enigma. What happens at the singularity? Does it signify a definitive end, a barring of entry to whatever lies beyond? Or could it be a gateway to alternate realms, a cosmic reboot, perhaps? Current physics gives us a cliffhanger, with general relativity drawing a blank at that point. As we dance on the precipice of knowledge, the singularity remains a tantalizing question mark. The singularity, this is where the fun begins. It is the ultimate frontier, a dazzling puzzle that invites scientists to leap beyond the known into thrilling territories of the unknown. Imagine the day when quantum gravity unveils the secrets hidden within and reshapes our understanding. Could it be that information somehow re-emerges or manifests in ways we can barely fathom? The mysteries behind these cosmic conundrums keep the intellectual fires burning bright, as black holes push the boundaries of what we think we know. Ultimately, black holes are the universe's delightful conundrums, challenging our understanding and compelling us to refine our theories. Each observation, every gravitational wave detected, and the myriad theoretical insights contribute to our growing tapestry of knowledge. While they remind us just how much we still have to learn, they simultaneously empower us with every new breakthrough. So here's to black holes' cosmic enigmas that not only humble us but also inspire us to chase the unexplored frontiers of existence with undying curiosity. Diving into the cosmos to study black holes is like embarking on an epic adventure through time and space. We humans are a curious bunch, always asking, what's out there? And why does it matter? This quest makes us unique among species. We don't just exist in the universe, we truly seek to understand it. As we unravel the mysteries of black holes, they shift from oddities of science fiction to our cosmic playgrounds, becoming exciting puzzles begging for solutions. Remember when the pioneers of physics stumbled upon black hole theories? They must have thought they'd fallen into a sci-fi novel, bizarre, almost ludicrous. Fast forward to today, and these celestial enigmas hassle physicists less than daily traffic jams. Armed with equations and models, scientists are forging ahead, making predictions about these mysterious giants, challenging our understanding without losing that sense of awe they inspire. The beauty of this ongoing saga is the transformation, the arc of comprehension. What was once a source of discomfort and uncertainty is now a well-loved theme in our scientific narratives. Instead of inducing horror, black holes spark curiosity akin to peeking into a magical box, where inside, strange but fascinating objects await. As we decode their secrets, we don't lose the sense of wonder. We gain the ability to influence how we understand the universe around us. But as we draw closer to understanding, we realize just how much power comes along with these discoveries. With every equation solved and each observation recorded, the once daunting mysteries of black holes become part of our arsenal of knowledge. They transition from alien phenomena to familiar entities in our cosmic neighborhood, straddling both the captivating and the comprehensible as we integrate them into our scientific lexicon. Now, dear cosmic traveler, your journey with me through the ethereal realms of black holes is nearing its conclusion. We've traversed the life cycle of these cosmic beasts, from stellar deaths giving birth to black holes to the astonishing ways they shape entire galaxies. Each twist and turn in this celestial narrative has introduced us to fascinating theories, dense equations, and questions worth pondering. What's more remarkable is that black holes serve as a stunning reminder of the surprises the universe has in store. They hold the potential for extremes, for beauty, and a taste of the uncanny that we still struggle to comprehend. Every time we gaze at the night sky, we're reminded that reality is often stranger than our wildest dreams, and the cosmos still hides many secrets waiting for the intrepid to reveal. So as we pack our bags and prepare to part ways, keep the marvel of black holes tucked away as a souvenir. They aren't just theoretical curiosities or distant anomalies. They are keys to understanding the very fabric of our universe. And who knows? Once we grasp the nature of black holes, perhaps the next big cosmic mystery is already lurking just beyond the horizon, ready for us to chase after it with renewed vigor. As you drift into the world of dreams, imagine yourself surrounded by the magnificent black holes of the universe. These colossal giants stand still amidst the cosmic chaos, each possessing an alluring allure that sparks curiosity. Picture glowing accretion disks swirling around them, seeming to dance like an otherworldly light show. The unseen event horizons beckon with a mystery that captivates the imagination, while the very fabric of space-time bends and contorts in the presence of their mighty pull. Think of the gravitational waves that ripple outward at the speed of light from colliding black holes, carrying whispers of their majestic collisions across the vast expanses of the cosmos. These waves are like cosmic messengers, sharing stories of events that occurred billions of years ago, with each pulse reverberating through the universe. And as you relax, let these powerful images spiral you downwards, settling you into a tranquil space where time ceases to exist, much like the peace found in the embrace of deep sleep. In this peaceful journey, let the realization wash over you that black holes have been watching us long before our planet existed. They stand as monuments to gravity's strength and bear witness to the cosmic dance of collapse and rebirth. Even as we marvel at their enigmatic nature, they remain unperturbed, patiently waiting while we explore countless questions about existence. In their silence, there's a profound invitation to ponder the cosmos's greatest mysteries, to look beyond the stars into the very essence of being. With each breath, feel connected to the fabric of the universe. It's an exhilarating dance of stardust and galaxies swirling together. As you surrender to sleep, imagine the black holes calmly spinning in distant realms, their presence a comforting reminder of vastness and complexity. There's an infinite world wrapped around you, and now, in this moment of rest, you're becoming part of that cosmic journey, aligning your rhythm with the grand orchestra of existence. Should the need for sleep begin to wane, there's always the option of a new adventure through a next video. However, if the gentle pull of slumber draws you, go forth. Allow your eyes to flutter shut and drift into the soothing darkness behind your lids. This isn't the void of a black hole. It's a healing embrace, a sacred corner of rest where your thoughts can finally take a backseat. Tomorrow, the universe will wait patiently with its enigmas and thrills, eager to unveil more secrets. For tonight, however, is dedicated solely to the serenity of sleep. With each moment of stillness, let your mind wander through the cosmic expanse until you sink into a deep, restorative slumber. Good night, and may your dreams weave across the endless tapestry of a universe filled with wonder and awe. Rest well, as the stars twinkle in anticipation of your return to consciousness.